Hello! Welcome to our first set of online notes. This set of notes is from Chapter 2.1, Matter Basics. For some of you, this will be review. For some of you, this will be all new. Write down the things that are new to you or that you need to be able to remember so that you have them in your notes. You can take notes on your iPad or on paper. Either way, just writing them down or typing them in will help you remember them. However, it will not be practical to watch this movie during a test. So please don't plan on just watching this and then never coming back to it until the test. In order to understand matter, we first have to look at the periodic table of elements. This is the paints that paint the world around you. These elements make everything. Everything you see, everything you touch, everything you breathe, and everything you are. You could not exist without these elements. And some of these elements make crazy, beautiful things. Some of these elements make scary things. But in the end, everything around you is made of these elements. Sometimes they're just alone, and sometimes they work together. So let's see how that works. When we look at pure substances, they can be an element or they can be a compound. So we need to understand which is which. Elements are made of atoms of the same type. No matter how small the material is cut, it is exactly the same. Everything in it is made of exactly the same atoms. Gold is a good example of that. Gold is an element. It is abbreviated with the letters capital A, small u. When you break apart gold and you cut it smaller and smaller and smaller, there is nothing else in gold other than that atom of Au. Doesn't matter how you break it, if it is pure gold, it is all Au. Salt, however, is a compound. They have more than one element that's bonded together. Another one that you think of often is water. You guys all know that if I say H2O, that's water. But that is made of 2 hydrogens and 1 oxygen bonded together. Salt is made of a metal, sodium, and a poisonous gas, chlorine. If you take this metal and this poisonous gas and you bond them together, you get salt that you can eat. But you couldn't eat either one of the parts that it's made of because they're both poisonous. This bulldozer is sitting on a giant pile of salt. If you look at that pile, every bit in that pile is salt, and it is the same NaCl. But in every bit of it, the Na and the Cl are bonded together, making the Na and the Cl different than the sum of its parts. If you take 2 or more substances together, you can get a mixture. Mixtures are different because they retain their own properties. For example, salt water is a mixture. You could put NaCl, which is salt, into H2O, which is water, and you get salt water. It's a mixture. But salt water is still salty, so the NaCl still acts like salt, and H2O is still wet, and so the water is still acting like water. But they're a mixture together, they stay dissolved together, and they act as one thing, salt water. They are a homogeneous mixture. That means that it's a combination of things that's evenly mixed the same throughout. No matter where in the ocean you go take a sample, the water is going to be largely the same. It's going to be salt water wherever you go. Because homo, the prefix, means same, or the same, or equal, or like. So you've seen the prefix homo before. We're going to use it this year as homogeneous, which is a mixture or combination that is evenly mixed. It's the same throughout, but each part. Another example is Gatorade. If you click on the link where it says Gatorade, you'll see a whole website dedicated to what Gatorade is made out of. I grabbed just a handful of the ingredients. Gatorade has in it water. It has sucralose, it has brominated vegetable oil, it has sodium citrate, it has natural flavors, and it has about 10 other items. Each Gatorade is going to be about the same, but it could be a little bit different from batch to batch. If you grab a sample though from the top or the bottom of the bottle, they're going to be largely the same. But any batch of the blue Gatorade is still going to be Gatorade, even if it had a bit too much sucralose in it or somebody messed up the recipe a little bit. It would still be Gatorade. Hetero is a mixture that is different. Hetero means other or another or different. A heterogeneous mixture is a combination that is not evenly mixed and varies from spot to spot. A good example of this is a blizzard. In the cup there's ice cream, which is a homogeneous mixture, and there are candy chunks. Those candy chunks are mixed throughout, and every spoonful you get is going to have a different combination of candy chunks and ice cream. And that makes that a heterogeneous mixture, a mixture that is different from bit to bit. Heterogeneous mixtures are going to sometimes be big and chunky like this, but sometimes they're just going to be small bits that are mixed together, but that aren't in perfect ratio everywhere. There's not a predictable pattern. When we're looking at solutions, if it's dissolved, it's called a solution. If it is simply being held up by the density of the liquid it's in, it's going to be a suspension. If you start to break the particles out and they settle at the bottom, that's a precipitate, and the liquid that goes to the top is a supernatant. Other examples of solutions, Kool-Aid and salt water. We talked about those. Suspensions have particles that are larger, that are floating or suspended in a liquid. Often they have a little bit of a milky appearance because the particles are reflecting back the light. And colloids are, one has a wide variety of different particle sizes in it. They will have a solution of fine particles, and they will have a suspension of large particles, and sometimes even a medium-sized particle kind of floating in between, and they all are together. And if you let them sit long enough, they will settle out into layers. And so paint is a good example. Blood, if you've ever had a blood sample, you'll see that they put stuff in to separate those layers out. And fog and smoke together make a nice colloid. So those are the basic information from chapter 2.1. If you have any questions about any of these, read through chapter 2.1 and ask away. The goal is to make sure that you have a source to go back to look, but also a little bit of basic information. Have a great day. Thanks very much. Bye.